What's up, you guys? Welcome back to another video. So I just recently uploaded a video about stored cross-site scripting and how we can use that to steal session cookies. And I actually got a comment on that video asking, well, hey, what about reflective cross-site scripting? Like, how does an attacker actually use that? So I did some research, tried to find a lab or some sort of demo environment where I can get hands-on technical on that. And so that's what this video is going to be about today. It's kind of a long one, but by the end of it, you should understand how reflective cross-site scripting works, how you can kind of hunt for it, and how we can steal session cookies with it. So hopefully you'll like this. By the way, I've started streaming now on Twitch, so please check out the link in the description. Give me a follow over there. I'd love to see you live on Twitch sometime, and let's just dive right into the video. Cool, so let's just go ahead and start diving right into our example here. So we're using the Portswigger Web Academy, but I'm not really trying to show you how to solve this lab. I'm just using it as an example to kind of showcase this reflective cross-site scripting and give you an idea of how it works and what it does. So in this one, it's different, right? Because last time with stored cross-site scripting, we made a comment or left a review, something like that. And we didn't send a link out. We weren't trying to get anybody to click anything. If the user just happened to browse that comment or browse to that comment or whatever, it would trigger the payload. In our case, we want to actually leverage reflected cross-site scripting. And so in this case, we need to be able to craft a malicious URL and get someone to go to that malicious URL to trigger this payload. And how do we do that? Well, one notorious feature that typically is seen and always should be tested for is a search bar. Anytime you see a search bar, oftentimes it's common to find reflective cross-site scripting in that type of feature of a web application. So if we were to just type in a quick, example here, I'll type 123 and we'll hit search. We can see on the results page, it reflects whatever we typed right back into the page. We can also see up here in the get parameter, or I guess in the URL bar, we have a get parameter for $search is equal to 123. So what that means is anything that we type here should get reflected back into the page, right? So we could try doing like 123 and throw in these special characters that I always like to use. We'll single quote, double quote, hit enter, and check that out. All of that got reflected right back to us. If we view the page source of this, we can search for 123, and I just did Control F, and check it out. So we found, here's our search term, and nothing is being encoded. Look at that. All the special characters are all being interpreted as actual special characters. That's awesome for us, because that means we should be able to, well, try injecting a payload. So what if instead of this, we had something that looked like that, and we try to inject a script tag, and then we just have, whatever it is we want afterwards. Let's just insert this, see if it takes. Okay, and we get a notice here that says tag is not allowed. So what that's telling us is it probably is seeing that as a script tag, and that's being blocked. There's some sort of web application firewall that's preventing a script tag. But no big deal, really, because if you go out to like payload all the things, it's a GitHub repository that has all kinds of awesome payloads. Definitely bookmark this one. But the one I'm looking for is obviously cross-site scripting. And there's just this list of all these different cross-site scripting payloads that we can use. And notice, if you look at them, they don't all require script tags. Like this one obviously does, but this one's using an image tag. We've got SVG, we've got div tags, video details, right? So there's all kinds of different tags we can use. So we just got to figure out which one of these tags this web application is going to allow. So we've got to try to figure out what's not being blocked, because obviously script tag is. Well, Portswigger actually has a really handy site. We can go to Portswigger, what is it, cross-site scripting. I think they call it cheat sheet. I think it's this one. Yes. No? Yes? Yes, this is it. So inside this cheat sheet, right here you've got these different I don't know, tables or whatever. I guess they're not really tables, but they've got different sections. So like everything listed here are different tags that can be used. These are different events within those tags. So for example, you know, you have something here that's like on load, right? So we could have a script tag, and on load, when the page loads, do something, right? So these are all just different events. First, we want to figure out what tags are even allowed. So I'm just going to say copy tags to clipboard, click that. And if we go into Burp Suite, we can actually use Intruder to help us kind of brute force this. Because what we want to do is we want to try these various different tags, right? So if script's blocked, what about image? You know, and if that's blocked, what about A for links? And if that's blocked, what about the next one, right? But obviously doing that manually can be a pain. So we're going to leverage Burp Suite. I'm just capturing this in repeater, or sorry, in intercept, and I can right click and send it to intruder. And we can actually come in here and do our own attack. So I'm going to clear out the default payloads, and I'm just going to actually redo this. And right in between those two angle brackets, I'm going to add, click that twice to go ahead and open and close. And that just means anything between these two symbols is going to be added. Any payload that we enter is going to be added right there. So we're just basically throwing all those different tags that we have on our clipboard currently in between those angle brackets. And I'm going to paste this. So now we've got all these different tags here as our payload. And whatever, let's just run it. Now, we are on Community Edition. I wanted to use Community because I know a lot of people don't have Burp Pro. But we're only sending about 156 requests. So I'm hoping this won't take too crazy long to go through. I'll go ahead and pause the video here, but all it's doing is it's just trying out each one of these different tags. And once this finishes, we can monitor the status and maybe even the length column to try to identify which of these tags are actually allowed, whereas all the rest of them are being blocked with a 400 error. Okay, so I will check you guys out in just a sec. Okay, so the attack's actually still running, but we can see already we got a body, when the body tag was inserted, that returned a 200 status code. So let's go play with that a bit. So if we come back, let's just adjust this to say body. And we still have intercept on, so we got to go in, turn intercept off. Probably have to reload the page here. Yeah, it didn't go through, I don't believe. Oh, maybe it did. Hit enter again. Okay, so check that out. We don't see the text body in here, but that's because if you view the page source, we actually broke out of this H1 tag, and now this just got interpreted as HTML code. So cool. We were able to inject a body tag, which is awesome. So let's go back to payload all the things, and let's do a Control F here for body. And let's see if we can find a body tag. So this one is using body on load equal, and then it just looks like it's doing some sort of alert. So we can copy this one, maybe keep that in the back of our mind. Is there anything else that we might see? Body on touch start equals alert. So this is just like the different events, right? On touch start equals, on load equals. These are the various different events, and this one should just do a alert. So I'm going to copy this, and proof of concept, let's go test this out. So we'll add this as our payload right there, and okay, we get a different error. So last time we got tag is not allowed, this time we're getting attribute is not allowed. So it looks like in addition to this being filtered, it looks like these events are also being filtered, and maybe on touch start is not an allowed event. So like before, you know, we can manually go through one by one, try these different ones out until we find one that's allowed, or we can just leverage the power of Burp Suite to do it for us. So I'll come in here, I'll say all events, and I'm going to copy those events to my clipboard, and we'll just do this again. I think if we look through, is it this guy? Yeah, let's send this off to intruder. I was just looking through the history to grab the last one we sent, and I'll replace this search term here with our angle brackets, and in between those we'll go in and add this. And actually what we want to do is we want to add body, right? Because that's what we're doing, and then we want to figure out what attribute or what event is going to be allowed. Okay, so let's clean this up a bit. We don't need to close it there. We are going to close it here instead. We'll have a space in between, which I'll go ahead and URL encode just in case. And then obviously whatever our event is, and we'll just set that equal to 1, just to make sure. Oh, I had went into the wrong place. Hold on. So I think I hit Control Plus and it somehow started a new intruder window. That's fine. So equal to 1, and we want to actually do Control U to URL encode that equal sign there. So this is just saying we're going to use the body tag, and then we're adding our sniper position here, and we're just going to equal that out to 1, and let's just see what happens. So if we come back here into our events, copy those to clipboard, we'll paste those through, and let's run our attack. Which again, will be slowed down, right, doing community edition. But as this goes, let's just look at one of these, right? So it came in and it said body on activate equals to 1, and the response that came back is attribute is not allowed. So now it's just going through each one of these, and I'll pause the video until hopefully we get an error status that, or I guess a response code that is not a 400. Okay, guys, so we have ran through about 88 or so payloads, and looks like we found one that actually replied here with a status code of 200. So looks like on resize is going to be allowed. So let's come in, make sure intercept is off, which it is. And if we were to come back to here, we can actually test this out. So instead of on touch start, what if we say on resize, hit enter. So what this payload looks like now is we're saying body on resize equals alert 1. So if the event on resize occurs, it should trigger our payload, which should just pop an alert. So let's try that. Let's go ahead and resize our window. Boom. We have cross-site scripting. This is awesome. So this is an example of reflective cross-site scripting, and I like this lab because it kind of shows you, what you need to do to brute force and actually identify which tags and which attributes are allowed. But we're not done. Let's take this further and actually get malicious here, because obviously a pop-up alert is good for proof of concept, but why does this matter? What can we do? Let's take it a step further. Okay, so let's go ahead and just clear out of this pop-up. We'll say okay, and let's go look at our payload again. So right now, all we're saying is do an alert here with the number 1, right? But what if instead of doing alert 1, what if we said do document.cookie? So what should happen is if I press enter, our payload should be injected to the page, and now we can trigger the event by resizing it. Boom, we got a pop-up, but the pop-up is empty. Why is this pop-up empty? Well, the reason is what I'm trying to do is I'm trying to say, hey, inside of that pop-up message, show me document cookies. Show me the cookies that are currently running in the user's browser. And if we go and we use, I'm just using here this cookie editor add-in to Firefox, highly recommend. But if you look at it, I do have a valid session token here, a valid session cookie. Even though I'm not logged in, I still have a session token or a session cookie assigned. But if we go into show advanced, we actually see all of these different flags are set. And the one that matters is this one right here, at least matters for this proof of concept, is HTTP only. And this is something that's really important to know, because if a web application sets the HTTP only flag on for session tokens or session cookies, that's going to really, really help mitigate against these type of attacks. And I just showed you why. We tried to use JavaScript to go and read this cookie, and because this flag was set, we weren't able to. JavaScript can't read it because this flag says HTTP only is the only thing that can. So I'm going to turn this flag off. I'm going to hit save, and we're just going to reissue the same request. I pressed enter up there, trigger the event with a resize, boom, check that out. So because the HTTP only flag was not set, now we get our session cookie returned to us. Now, okay, I said I was going to get malicious. This isn't really malicious, right? Because why does it matter? A session cookie being shown to the user who signed in, whatever. Like, why do they care about seeing their own session cookie? We want to get real malicious by having the session cookie sent to the attacker instead. So let's come back in here and we'll just say okay through these. And if we look at our payload again, what if instead of saying document cookie, or instead of saying alert the document cookie, what if we told it to actually send it out to us? We can come in and we can say document.location is equal to, and then we could specify a remote address. So I can come in here and say like badsite.com slash, and then we could say anything. We could say like question mark XSS is equal to, and then we have the value here of document cookie. And I think that the way that we need to format this is keep that at a plus mark and just make sure it's clean on the other end as well. So check this out. So what we're saying here is document location is equal to badsite.com. By hitting enter, what's going to happen is when this resize event occurs, it's going to submit our document cookie as a get parameter to badsite.com. So that means if we are monitoring, if we had control of badsite.com and we are able to see anytime someone issues a get request to badsite.com, we should be able to see this value that gets passed to us in that get request. Okay, so guys, I spent the last hour trying to actually prove what I'm telling you would work. And here's the thing. I put in a domain that I actually owned. I put in a DigitalOcean IP address that I own. I even used a site called website.hook, and I couldn't actually do anything where it would send me the document cookie. I did redirect, but I just got an empty XSS parameter every time. The only thing I can think of as to why that's happening is because of that HTTP only flag being set on the cookie. So while I've got the ability to come into my cookie editor add-in and disable that client side in my browser here, I'm wondering if the fact that that flag was set is actually still preventing the attack, because I'm just wondering if maybe that's what's going on. So I can't actually prove it to you using this lab. Sorry about that. But in theory, this exact link would be a perfect example of a reflective cross-site scripting attack. Now, in this case, it is still not the best, right? Because in order to actually get the victim to exploit this, you have to convince them to not only click a link, but also manually resize their window in order to trigger that event. So how realistic that is, I don't know. I mean, I think if you're a good social engineer, it's not going to be too difficult to come up with a ruse to force them to do that. But there is a better way, and let me show you the better way. So in this lab, they actually give us an exploit server that's going to just basically demonstrate what an attacker web server would be, and I'll show you why that's given to us here. But basically, if we come back into what we've got going on, I've just got a blank payload again. So let's just go ahead and redo our payload. So to start, we'll say body, and we will then do a space, and we'll say on resize. We'll say equal to, and then we could do the whole document location thing. I'm just going to straight up do alert, I don't know, XSS to begin, close that out. Let's just make sure this works. So we come in and we resize this. Bam, we get the alert to pop. Perfect. So in the exploit server, instead of making the victim, click the link and then resize it manually, we could leverage our own web server to do that for us, right? We could actually come in here and we can embed our own iframe. And to do that, it would look like this, and we would just say iframe source is equal to, and then whatever address it is that we want our iframe to be. And an iframe is basically just like an embedded website inside of a website. So we could take this link that we already have that contains our basic alert payload, and if we paste that in here, now what we're saying is if you go to this address, this is the web address of our exploit server, and we're just saying /exploit because that's where we're hosting this file. We could buy our own domain. We could host this up on our own DigitalOcean box, have the same HTML code. It would be fine. Like the same idea would work just fine there. They're just giving one to us, so we don't have to host it ourselves. But we have the iframe, The reason why we'd want to do this is because when you have an iframe, you can actually come in now and we can say on load. So when someone actually loads this, then we're going to go ahead and say this style width is equal to like 1,000 pixels, right? And so by doing this, what we're basically saying, I think we got to add some quotes here, close off our open tag. What we're basically saying is as soon as someone browses to this malicious site, we're going to have an embedded iframe, and as soon as that iframe loads, it's going to adjust the width to 1,000 pixels. Well, hey, when we adjust the width, that's going to trigger the onResize payload, the onResize event, which should then trigger our alert payload, right? A lot's going on here. There's a lot of moving pieces to this, but let's just go ahead and see if it works. So I'm going to store it. This is just basically like writing that file to the web server. And then by clicking view exploit, that's basically the same thing as just going to that malicious link. And we should see, we get a box. Check that out. I don't know if you saw it, but I mean, obviously the alert pop-up worked. But if we go back and we do it again, we get a small box that shows up. And then it quickly expands on load. It expanded to be the full size. That was the onResize event. And then because the resize event occurred, it automatically caused that pop-up to occur. So we could actually come back and instead of alerting this, we could say alert document.cookie, store that, view the exploit, bam, resize, and it didn't work. Let's come back real quick. It's probably because of these quotes here. It was taking that like as literal text. Store it again. View the exploit. Check it out. Awesome. So we actually got the session cookie to be sent to us. Now, this wasn't really sent to us because all that we did is we manually browsed to this site. So this would be the link we throw in a phishing email to the victim. They browse to it, they get this to happen, and then they view their own session cookie. Not too exciting, right? We don't, as attackers, we don't get to take advantage of that. But that's where that whole thing I was talking about earlier, where you say document location is equal to badsite.com. I think you have to have your actual HTTPS or whatever, badsite.com. And then you could do your slash whatever, XSS, however you want to do it, equal to, add in your document cookie like this. Perfect. And basically now, if someone has control of this badsite.com, by a victim clicking this link, it's going to trigger everything we've got going on, and it should end up sending that document cookie off to the victim. Again, though, that one requirement was that HTTP only is not set on the actual session cookie. I hope any of this made sense. I'm sorry I couldn't actually show you this further. I got really deep into this before I realized this lab adds a bunch of complexity because of the fact that it actually sets that flag. So that sucks. It wasn't what I was hoping for, but I still hope you learned something, and hopefully you found this of value. Whew. All right, so we made it through that one. Yeah, that was over 20 minutes. A lot of technical stuff, but I hope that maybe you actually learned something. I know going through the process of having to learn, I mean, I knew some of that stuff from just going through PoC Academy, but actually having to try to teach it and explain it definitely made it worthwhile. I'm glad I made this video. Hopefully you learned something as well. Lots of big stuff coming up on the channel. I'm doing a lot more web application, web security type videos, kind of coming in the pipeline just because it's so fresh in my mind. I started a new job where I'm focused on web application security. But I am also, hopefully, I've got some opportunities to start working as a contractor again, doing more network and social engineering engagements, and that always, anytime I'm working on those type of stuff, I get inspired to make videos related to that content. I've also got a lot of new people coming on the channel, doing interviews. For the last 4 weeks, I've always had someone come on and interview some other content creator in the space. So I hope you guys like what's going on with the channel lately. I'd love for any feedback, any comments that you'd want to leave. If bare minimum, smash that like button for me. And yeah, I'll just catch you guys in the next video. See you soon.